All right, first step. First step, which of course is the key step in these. Right? Now, a common mistake I see people make is when you do the derivative of 2y, I'll sometimes see people have 2y, y prime. Remember, we tack on a y prime whenever we do the derivative of something with a y in it. Well, what's the derivative of 2y? It's just 2, right? Just like 2x, the derivative is 2. So the derivative of 2y is 2, tack on a y prime. So it's 2y prime. Okay, now if you had y squared, that's different. If you had y squared, the derivative of y squared is 2y, tack on a y prime. Then you get 2y, y prime. All right, so derivative of 2y is 2, tack on a y prime. Derivative of x squared is 2x. This is where we don't tack on an x prime, because that's just 1. It's with respect to x, dx over dx. 2x. Derivative of sine y is cosine y, leave the inside alone, times the derivative of the inside. Tack on the y prime. Okay, then what do we do? Get y prime on the same side. So we need to subtract this cosine y, y prime over to here. And the whole reason for getting them on the same side? Factor out a y prime. So we factor out a y prime, we have 2 minus cosine y, and then we can divide it over to the other side. And your answer will have both x's and y's in it. A lot of the time. Not always, but a lot of the time it will. Sometimes it'll have only y's in it. Okay? Let's try another one of those. 3x to the 4th minus xy equals negative 2 y to the 3rd. Negative 2y to the 3rd. Oh, and let's make this y a y squared while we're at it. What the heck? Let's just here. Let's make that y a y squared. Okay, now go. Yeah, we could have an e to the y in there. We could, but we won't. All right, we'll leave it at this. Now, before you get too far, maybe I should say that I assume you all saw the product rule in there. Okay? I can't tell by... Sometimes when I say that, I get a, oh, I didn't notice any reactions there. Where's the product rule? On the xy squared, right? And the smart way of doing that would be to attach the, right here, the negative with that. So treat this negative x as one thing and the y squared as the second thing on your product rule. And that way, otherwise, you're going to have this minus, and of course, product rule is a plus, and you're going to have it in parentheses, and you're going to have to distribute, And if you attach the negative to the x, then you have to worry about that. So it would look like this. Your first step would look like this. 12x to the third. Product rule means a derivative of negative x is negative 1. Leave the y squared alone. Now you leave the negative x alone. See, that way that negative distributes through there automatically. You don't have to worry about it. So negative x left alone, and then the derivative of y squared is 2y, tack on a y prime. We don't tack on a y prime on the first one because we didn't do the derivative of y. We left the y squared alone. And then on this side, we get negative 6y squared y prime. Okay? Now, a little bit of a pet peeve of mine, and I know I said rearranging isn't that big a deal, but don't leave that 2 in the middle of that term. Okay? I mean, on this step's fine, but now when you go ahead and rewrite it the rest of the way, pull that 2 out in front of there. To pull it out in front? Yeah. Well, we just don't, you know what I mean? I mean, we write 3AB, we don't write A3B. You know what I mean? We always put the coefficient out in front of the letters. But would it be wrong? You know, no, I'm probably not going to count it wrong. But it will bother me. It will be like fingernails on, you know, some of you guys will probably leave it that way just to bug me now, probably. But that's, all right, so anyway, we got to get our y prime terms together, so go ahead and add that over to the other side. Add this term here to the other side. Plus, the people I've seen do it usually mess something up. I think it messes you up. I think when you look at that, it just looks different. There's something different about it. I think put the 2 out in front, it's easier. Anyway, move that to the other side. Looks okay? Well, that's fine. Just the y prime term, because you're trying to get the y primes on one side together and the ones that don't have y primes on the other side. The reason for that is because our next step here is going to be to factor out a y prime. Right? So we want only the y prime terms together on one side. All right, so once we get those over there, then we can factor out the y prime on the right, and then we can divide by that quantity over to the other side. Now, if you grouped your y prime terms, I'm not sure why you would on this one, but sometimes it's, you know, you have some y prime terms here, some on the other side, and maybe you decide to get the y primes on the left, and so you moved all these over here. That's fine. Yours will look a little different. All your signs would be opposite, but that's the same. Opposite the top, opposite the bottom, the opposite to cancel out, and it'd be the same thing. So either one of those would be okay. All right, so now you can make these up. I mean, I made this one up. I mean, just make up a problem. It's got a mixture of x's and y's. Throw in an e to the y, maybe, and a sine y like the last one, and you can make these up all day long. The question is then, how do you know if you're right? So work with a partner who knows what they're doing, I guess. I don't know, something. But implicit differentiation, there's going to be at least one of those on there. Could be more than one. All right, let's see if there's anything else interesting here. There's a few more on this page that have a mixture of x's and y's. Arc secant, we said we wouldn't have that. Yeah, let's don't do those. Let's go to the website here. Let's get some log ones. Let's see, what's level 4 look like? Might as well. I don't even. It's funny, on some of them, 4 are almost. The thing I notice about Quite Nasty is they just do multiple layers of chain rule. And I'm not going to do that many layers, so I don't think that's probably as good a one. 3 actually is more nasty sometimes than 4, it looked like. Yeah, the A is the arc sign, arc cosine. Let's find one here.
Oh, see, I thought it was the.
Here we go. Here's a good one. All right. Let's do that one right there. Yep. Oh, shoot. Sorry. All right. Yeah, there at the end, it's times cotangent, so you have a product rule there at the end, right? So the first one, the 2 secant, the derivative is secant times tangent. And then the 8 times the log, you just leave the 8 there. The log base 2, the rule is 1 over x times 1 over ln 2. Now that I could put together, but that's not a big deal to me if you do or not. So you could have the 8 on top, the x ln 2 on the bottom. I don't care about that. It's fine. Okay, and then I got a big set of parentheses for my product rule here, which in the end turned out not really be necessary. I mean, it's just this plus this plus this plus this. Derivative of x to the 3 halves, or no, is it 3x to the 1 half? So bring the 1 half down in front, be 3x is negative 1/2. Cotangent left alone. Plus, leave the 3x 1/2 alone. Derivative of cotangent is negative cosecant squared. And that's where the parentheses are important. And I would bring that negative out in front with that plus and turn that to a minus. And I think that should be done. Okay, and that's it. That's it. Again, like I said, this is more typical of what the problem would look like as far as having to go through and do this, and really not much simplifying to do at the end. Any questions about that one? Now, I've purposely picked, you notice here I've picked a to the x and log base a and secants, and the ones we haven't done a lot of, those are the ones you really got to read over your rules and make sure you know those rules. Okay, let's do, let me make up one here. Let's do a let's do a quotient rule where there would be some simplifying to do. Let's say you had this. Let's say you had e raised to the x squared plus 3 all over sine squared x. Now, there is going to be a little simplifying to do, and word of caution, the bottom, what do you got to think of on the bottom? Sine all squared. Be really careful there. Sine all squared. Okay, try that one. There we talked about quotient rules where you sometimes get some simplifying. Not always. All right, here's what I've got in the first line there. Oops. Questions there? Derivative of the top, you kick out a 2x. Bottom left alone is sine squared. Minus the top left alone. And then the derivative of sine all squared, you bring the 2 down in front. Leave the sine alone. Times the derivative inside. Derivative inside is derivative of sine, which is cosine. So you'd have 2 sine x cosine x. Now I didn't put in parentheses there, but I didn't need them. Right? Because each thing is just an individual term. There's no pluses or anything in there. So when I did the derivative inside, it's just that. Okay? Questions on that now? I see a few puzzled looks. Then the bottom square to be fourth power. Now what do you notice you can simplify? Factor out a sine. Now you can also factor out a 2. You can also factor out an e to the x squared plus 3, but there's no need to. You can factor those things out, but they're not going to cancel with anything. But if you factor out a sine, it'll cancel with one of the signs down below. And you'll end up with sine to the third. So I just went ahead and wrote it. I didn't factor out the sine. If I factor out a sine, I'll have one less there, so just a sine. And I won't have a sine there at all. And that sine will cancel with one of them down there and give me sine to the third. Yeah.
This is how you got the sine x times cosine.
Okay, it was this right here. Right? The bottom is actually this. Right? So when I go to do the derivative of the bottom, which is this part here, derivative of the bottom, bring the 2 down in front, leave the sine alone, which would be to the first power. You bring the 2 down, you'd have 2 sine to the first, times the derivative of the inside, derivative of sine is cosine.
I canceled like 2 of the signs on the left side, and then I canceled 1 on the left. So
And wrote it as 2 separate fractions? Yes. There is also the ability to split this up. We have a single denominator. So I could put this over this, which would cancel another sign and leave that as sine squared. And then minus, and then this over that with a cube. And that is perfectly fine as well. Perfectly fine as well. The only reason I don't do that as much on these is a lot of times, remember, what are we most interested in when we do the derivative? Setting it equal to 0 and solving it. And usually you want to keep it as one fraction when you set it equal to 0, because when does a fraction equal 0? When the top is 0, then you mess with that. So that's the only reason I don't do it, but that's perfectly fine to do that. And that works well in quotient rule, because you always have this minus this, usually over a single thing. Splitting it into 2 and looking at it that way is not a bad way to think about it as far as reducing. So that's perfectly fine. Perfectly fine. Okay? Now, and that happens, listen, if you ever have something to a power on the bottom, think about this now. Think if you just had a quotient rule where you just had x cubed on the bottom, or you had some stuff cubed. Think about what's going to happen when you do the quotient rule. The first time through, you're going to leave the bottom alone, so you have that stuff cubed. The second time through, you're going to do the derivative of the bottom, which means you bring the 3 down in front, leave the stuff squared. So each of these terms is going to have that stuff, one time to the third power, one time to the second power, and then the bottom is going to have that stuff squared. So it's going to be down there. You see what I'm saying? So you're always often going to have that situation, especially when the bottom is raised to a power, where you're going to end up with some of that you can factor out. In this case, it was sine, where you can factor out and cancel. So it's not that uncommon. And this, to me, would be a more representative one of where I would want you to do a little bit of factoring and simplifying, not those ones in the beginning of the day with the negative half powers and all that crazy stuff. That got a little beyond what you really need to worry a whole lot about tomorrow. Yeah?
So if we did factor out the 2 and the e to the x squared plus 3 on top, it doesn't really do anything, but is it wrong?
No.
Okay.
Yeah, that's not wrong. No, not at all. It's just that I just factored out what I needed to cancel, but to factor out the other stuff is perfectly fine. Okay? All right, let's see what else the website might have for us. Let's pull back in some of these other things. Sine, cosine, maybe get an inverse trig in there a little bit. Oh, easy. Easy's good. That's a little, God, boy, it just jumps from unbelievably easy to crazy hard. That's let's do that. And that is the difficulty of this website is, you could go and do one, and you're like, gee, should I be able to do that? Should I? So at least as we're doing this, you get a little sense of what I'd want you to do. Some of those where you get 4 layers of stuff inside of stuff and decimals, and we haven't done anything like that, so don't worry about that. This A cosine, now remember, is arc cosine. Right? That's arc cosine right there. Okay. Okay, here's what I got. There's a product rule stuck in there, right? Product rule right in the middle. Again, good idea is to attach that -3 to the e to the x. Make that your first thing. So derivative of cosine is negative sine, so -3 sine. And then our product rule, leave the negative, or derivative of -3 e to the x would be -3 e to the x. Leave the arc cosine alone. And then minus the 3 e to the x left alone. And then the derivative of arc cosine is -1 over the square root of 1 minus x squared. And then plus the derivative of sine is cosine. And the only thing I would simplify there is those negatives. Turn that to a plus, that term there. And you could move that 3 e to the x up on top. You wouldn't have to. It looks better if you do. And that's it. Again, that's another one where, that's kind of a medium to maybe look, I don't know about hard, but I mean, it's got arc cosine in it. It's got a product rule in the middle of it. The nice thing about that, there's no inside stuff that you got to kick out anywhere. So you have to worry about that. There's very little simplifying to do. But again, it shows that you know those different rules. And so that's important. Yeah. Yes. And I think it would be good if you did. Let's get a natural log in there too. See if we can get it. It's funny. You go to 4 and it doesn't do any. Oh, there's a little bit of a chain rule. It doesn't hardly do any inside things. Let's go back to this page, see if we got anything here. Too easy? Do that one. Try that one. All right, here's what I got. Key thing is remembering that 2x minus 1 and getting it in parentheses. Also remembering the ln3 because it's 3 to the u. There's really nothing to do with that. I mean, you can factor out a 4, and there's no canceling to do, so there's no reason to factor. Yes. This, if you did what? What else would you do? Like leave it there? Oh, yes, yes. Oh, I'm glad you said that. Yeah, no, so you end up with negative 4 over x squared. X minus 4 over x squared. The problem with doing that as a quotient rule is if you do this as a quotient rule, you do the derivative of the top, which is 0, times the x left alone. So you don't get x minus 4. Because quotient rule says derivative of the top. Well, derivative of 4 is 0. Leave the x alone. And then minus the top left alone, then the derivative of the bottom, which is just 1, over the bottom squared. So what you actually get is negative 4, like I was saying, negative 4 over x squared is what you should get. Yeah. See, the problem with, anytime I have a constant, like if I have x over 4, I definitely don't want to do a quotient rule because I can just write that as 1/4 x and then the derivative is just 1/4. And if I have 4, so anytime I have a constant by itself in the top and the bottom, I don't like to do quotient rule because for that very reason, we mess it up. We mess it up because the derivative of 4 is 0, so that wipes out the x. So that's where. Because then it should be the same. So that would be the same if you did get 0. So you could do it as a quotient rule. We just tend to make mistakes there, and that's what throws us off. Okay? All right, rest of that okay? Yes.
I just did an entirely different. I just multiplied them together to be a quotient rule.
So you had 4 times 3 to the x squared minus x, which is perfectly fine, all over x. As long as you don't take the 4 times the 3. But leave it like this, and now do a quotient rule. That would work fine. It ends up being the same. It would simplify. Yes, that's perfectly okay too. All right? Good. That was a good one. Well, listen, let's end hopefully on a positive note. Let's do that one. Not that that one's incredibly easy. There's fractions in there and stuff, but hopefully this would be on the easy end of the scale. Easier. And so just to remind you that you want to be able to work with some fractions, because that does happen from time to time here. So we hate to miss the fraction one where that, especially if that's the difference between getting it and not getting it. But that's what I have right there. 2/3 times 1/5 would be 2/15, right? Fraction, just multiply the tops, multiply the bottoms, reduce if you need to. Negative 1/3, of course, 2 to the x, tack on the ln2. So it'll be something like that too, right? I mean, sure. There's some easy, some medium, some hard. That'd be in the easier category probably. All right, homework is to study more. Get on that website. Get those PDF, work through some of those PDF ones on the website.
You just thought of it.